The first thing that we do to determine the rate of change of radius is to convert the given information into the mathematical equivalent. So we are told that the area of circle is decreasing at the rate of 122 meters square per second. So using derivatives, I can represent this as dA over dt. This is equal to negative 122 meters square per second. I put the negative because it is decreasing, the area is decreasing at a constant rate. Here A represents the area, and the second information is area equal to 64 pi meter square at that instant. So I can write down this as area equal to 64 pi meter square. Which means I can find the corresponding radius at that instant by using this area formula of the circle. So I plug in pi r squared for area equal to 64 pi. I can ignore the unit for now. So I can cancel both sides by pi, or I divide by pi. I will get r squared equal to 64. So to find the value of r, I take square root on both sides. I get 8. I can put the unit as meter. So radius we have found out is at that instant the radius is 8 meter. We know how to find the rate of change of radius. So the mathematical equivalent of this is basically we have to find dr over dt. So to find this, once again I'm going to use the area formula, that is A equal to pi r squared. I differentiate both sides with respect to time. Differentiate with respect to time. So when I do that, if you differentiate area with respect to time, we get dA over dt. This is equal to, I keep the pi constant because it's just a constant, and then differentiate the r squared with first, that is using the power rule, we put 2r, and then we have to differentiate the r alone using the chain rule. So when you do that, we get dr over dt. We now plug in all the values which we have found out earlier. That is dA over dt is negative 122 meters square per second. So I can put only the number over here without the units. So I'm going to put dA by dt is negative 122. This is equal to pi times of 2 times of radius is 8. I put without the unit dr over dt, which is what we have to find. So let's simplify the right side. This is equal to 16 pi times of dr over dt. Now we have to solve for dr by dt, which means we have to divide both sides by 16 pi, this quantity. So when you do that and rewrite, we get dr over dt equals minus 122 divided by 16 pi. So we can plug this into the calculator, and when we do that, we get approximately negative 2.427. And we put the unit of this rate of change of radius as meters per second. So this is the value which we obtain. We are getting the negative, which means at that instant the radius is also decreasing. So it's decreasing at the rate of minus 2.427 meter per second. This is the answer for the question.